Good morning, everyone. Thank you for joining me. My name is Nathan Heston. I'm a trainer here with Briggs & Stratton Energy Solutions. And today we're going to be talking about whole home backup featuring the Sol-Ark 15k and SimpliPHI batteries, generators as well from Briggs & Stratton. This is a NABCEP certified training. And if you're here for continuing education credits, we do need you to stay through the end of the presentation. We'll give you our email address and we'll ask that you send us an email after the training asking for your certificate if you want it. I'll check the attendance logs and get those issued tomorrow. This talk is primarily about energy storage systems for the whole home. We'll be talking about how to do that. We'll also talk about the potential to integrate generators, etc. We'll cover topics like combining batteries. And if you have questions as I'm going through this training, feel free to enter those in the Q&A. I will try to monitor that as we're going, and I'll also save some time at the end for questions as well. So thank you for joining us. We are hoping that you learned something out of this training, and I'm glad to have you with us. All right, so if you're not familiar with Briggs & Stratton, we are a 117-year-old U.S. company. We've got a lot of manufacturing facilities across the United States and really across the world. We manufacture batteries and generators related to energy storage, as well as a number of other equipments in our different divisions. But in Energy Solutions, we focus on the lithium iron phosphate batteries that you can see on the top of the screen there. So there's a stackable 6.6 kilowatt hour battery that can be stacked up into stacks of essentially 20 kilowatt hours. We've got an energy track monitoring platform as well. That's an app that you can use on your phone or your tablet to see the systems that you've installed and monitor them. We also have a high voltage line of batteries as well. In addition to the Phi and Amplify 3.8 kilowatt hour batteries, which are a little bit smaller format, and can fit into our enclosures. The high voltage line is typically used for three-phase 208, 480 volt systems. You can go up to 1200 volts with those stacks, and I'll have a few slides on that, but for the most part today, we're going to be talking about residential home backup. Our generator line as well is we have a large line of generators that serve the residential market as well as high voltage generators that can serve larger markets, and transfer switches that integrate load management as well. So there's some advantages to using our transfer switches, and they do come into play with residential systems. So one of the things that we're doing as well is partnering with Sol-Ark on our ESS system. Sol-Ark has long been one of the leading inverter brands out there for whole home backup. They introduced whole home backup really with the introduction of the Sol-Ark 15k. And it's an excellent partner for us because of how well it is suited for integrating generators, and for taking advantage of batteries, AC and DC coupled solar. It's really an all-in-one. And we've had a lot of good experience, good feedback about support from both of our teams. Sol-Ark and Briggs & Stratton work hand in hand in this partnership to help you as you're installing energy storage systems on residential applications. So I want to start off at the beginning of this training just by level setting. The most common method for whole home backup is still generator-based systems. But since about 2015-16, we've seen a lot of growth in battery-based ESS systems. And Briggs has been there. SimpliPHI has been producing these home battery backup systems since 2010. Other companies are doing similar things. In 2016, Tesla introduced the Powerwall. Many companies are out there. We're seeing a shift towards battery backup systems. We're also seeing players that are promoting hybrid systems too. And so the most common method of backup is with generators. And there are some advantages to generators in that you have you have long duration run times. Typically, you might have a municipal natural gas supply. So Briggs & Stratton makes gaseous generators. We make generators where the engines run off of propane and natural gas. We don't make diesel generators. So the residential systems that you can see are basically function in a fairly simple way. There's a transfer switch, and either the home loads are being run off of the grid, and where that grid passes through a meter can passes through a transfer switch and covers the home loads. In the event of a grid down, time, the generator will auto start based on auto main sensing. It senses the grid goes down, it starts up, that energizes a transfer switch, it pulls a solenoid into the position of the transfer switch, and then the generator can feed the home. So it's either or. It's either the grid or it's the generator powering the house. So that's the typical way. We are seeing more and more systems when you combine it with a Sol-Ark, where you're having both generators and potentially solar, but both generators and batteries working together for hybrid systems. And this does a number of things. It reduces runtime on the generator. It burns a lot less fuel because you can run that generator at more optimal loads, higher loads, which are more efficient at producing kilowatt hours. And so you're saving fuel, you're saving runtime, you're saving maintenance on that generator, and you're generating electricity at more efficient and cost-effective prices. So understanding kind of where we're coming from with that background that, backup systems have traditionally, for the past, 40 years or so, been generator-based systems. The newer systems, let's level set. So the newer systems based on batteries could operate in a very similar way, in which the inverter at the heart of the ESS system would essentially be like that transfer switch. When grid is present, power can come from the grid, flow through the inverter, charge battery up if the battery's been drained, and then flow through the inverter to also power the home's electrical loads. In a grid down event, that power could then flow out of the batteries and cover the home's electrical loads until that grid comes back up or until the battery runs low. Well, the other thing about an ESS system is you can incorporate multiple power sources, and the inverter is there to manage those power sources. And so it's more than just a transfer switch. It's a programmable energy control device. And so if solar power is available, you can use that power to cover the home's loads. If there's more solar power than is being used by the home, that solar power can also be used to charge the batteries. But, a whole home inverter like this Sol-Ark 15k can also incorporate a generator. And so if the solar is unavailable, or if solar is not even attached to the system, in a grid down event, the inverter can pull power from a battery to cover the home's loads. And if that battery gets low, we can charge the battery by starting up a generator, using that to cover the home's loads and to charge the battery up. And we can program how quickly we want to charge the battery. So there's a lot of control based in these systems. Of course, at the core of an energy storage system is a battery. So energy storage in the solar world really means batteries, right? So you could just kind of highlighting what we were just talking about. So for a battery energy storage system, if the grid goes down, as shown by this red X here, that battery will discharge, cover the loads in the house. If you incorporate solar and there's enough solar available, that solar can cover those loads in the house and also charge up the battery during the day. And then the battery can discharge at night. So you're doing self-consumption as well. So it's not just a backup system. And that's the big difference, I think, between a generator-based system is there to back up the house. It's either on or off. It's only there to back up the house. Whereas a battery-based system, you can essentially get it to pay for itself. You can make your money back that you've spent on the system by self-consuming energy that you can produce with photovoltaics, with solar panels, with renewable energy sources. You can also do other things like buy electricity cheaply at nighttime and then discharge that battery during the day. So doing something like grid arbitrage, as we call it. And then with time of use settings, we can also, if you have peak demand charges at certain times during the day, then what you can do is you can choose to use time of use settings on the inverter to choose to discharge those batteries when electricity is expensive. So what exactly do we mean by whole home backup, and what's the difference between kind of the traditional battery-based systems? So traditional battery-based systems, you're looking at a system where you might only back up some of the loads in the house. And this has been the way that home systems have been, because most of those inverters that were first on the market didn't have the power to cover the whole loads in the house. For example, the initial power walls that came out, right? They could back up about 5 kilowatts. 13 kilowatt hours of storage, smaller systems, and they didn't have the ability to back up the entire home. So you would put some core loads on there, like your refrigerator, your lights, communication systems, the things you want backed up in a grid outage, but you might not put things like the stove on there, or the electric water heater, or the washer or dryer. And so we do what's called a partial home backup. In a partial home backup scenario, as this dashed line indicates, the inverter isolates itself from the main panel. We don't want to be energizing the main panel and sending electricity back onto the grid and potentially harming somebody who's working on the lines. And so what we do is we back up just the core critical loads with partial home system. Well, look at the difference on the right side of the screen. You're showing the whole home. Actually, showing the 12K inverter there, but meant to show the 15K. This is a whole home backup example in which we've got power coming from the main grid, and in a grid outage, the inverter isolates itself from the grid. But notice that the entire main load center of the house is backed up. And so we do this by having a large pass-through of the inverter. So for example, the Sol-Ark 15K has a 200 amp pass-through, so you can feed all 200 amps through the busing, the AC busing, and the relays on the inverter and into the main load center of the house. The battery system, and then in a grid outage, can keep that the loads alive, and solar can contribute to also support those loads and to charge the batteries. Additionally, you could have AC coupled solar, or you could integrate a generator into this type of scenario. So let's look at a simple example. So this is a wiring diagram showing a simple example. So you see some solar panels there. The idea is that those solar panels would form a string. We can bring up to 6 strings into the Sol-Ark. We have 3 independent MPPTs on a Sol-Ark 15K as shown. Those are rapid shutdown modules. So after 2019 on your roof, if you did a roof mount array, you need essentially little relays that will turn the panels on and off at the panel level, meaning at the panel location. So not only does the string have to shut down, but the DC output of the panels have to shut down as well. So those are rapid shutdown modules. And they are kept alive by what's called a keep alive signal that comes either from the inverter if you're using an AP Smart transmitter, or from maybe Tigo is another example, a good example that can offer optimizers as well. And then there's a rapid shutdown by code. This has to be accessible by emergency workers. Like it should be on the outside of the house, and this will shut down all production from the inverter. You're looking at a disconnect here. So you do have to have a service rated disconnect between the meter can and the inverter. I know there's been some confusion around that. And in fact, we even would recommend this be, a 3-way switch, so you could potentially bypass the inverter if you ever need to do work on the solar system. You can keep the loads alive for the house. So this is a simple example, and we're showing it here with a Sol-Ark, or with the Sol-Ark 15K and with a Briggs & Stratton 3 6.6 batteries, making a stack of about 20 kilowatt hours there. Here's another system shown with optimizers. So you've got optimizers. So if shading is an issue, you might go with optimizers, and they give you panel level monitoring. So we installed some Tigo optimizers recently, and it's nice to be able to see the production of each of your panels. And if you do have shading issues, these can boost the output of your solar. I'm showing this with a larger cabinet here. These are 12 of our 3.8 kilowatt hour batteries there. Those are 9540 certified in that BOSS 12 enclosure. And we have a heated option for these as well. So if you're installing outdoors in cold environments, that might be a good option. We're showing also a generator integrated. So this is an example of a hybrid system. And so we're showing a generator integration. If we could feed this into the grid port of the inverter if we were using a transfer switch, or we could feed this into the generator port of an inverter. Here's an overall larger system. I'm showing here a larger system where we've got 2 BOSS 12 cabinets there, kind of going through a DC combiner. Anytime you parallel inverters, you have to combine into a single battery bank and then power the inverters each individually off that combined battery bank. You could also use power distribution blocks as a combiner if you've got DC breakers built into your system elsewhere. I'll show a little bit later battery combiners using the Victron 1000 amp combiners. where you have Class T fuses that you can use. Notice that this larger system has 400 amps of pass-through, so each inverter offers 200 amps of pass-through. Got separate breakers there showing separate disconnects, 200 amps each, feeding each of these. And then that overall load center of the house could be up to 400 amps. So a separate option there. Here are some wiring diagrams out of a Sol-Ark 15k manual, and we're showing the generator coming into the gen input. So, a lot of questions. Can we integrate a generator? Is it easy to do? Sure, it does need to be 240 volts. If you have a two-wire signal to start, that's preferred, because then the inverter can start and stop the generator only when it needs to, when batteries get low. This is shown with DC solar. So the Sol-Ark has the ability to take in AC coupled solar, but it does that through the smart load port labeled Gen here in the diagram. So here's that example of a generator coming through a transfer switch. The generator is coming through a transfer switch here, and that would give you the ability to bring in a larger generator. The generator port on the Sol-Ark 15k is fused at 100 amps. It's a 80 amp continuous port. So 19.2 kilowatts. So if you want to bring in a larger generator, like a 26K, you can bring that in. You certainly could connect a larger generator to the gen port, but you would have to derate it down to 19.2 kilowatts. If you bring, one of the Briggs & Stratton 26Ks in, then you would need to do that. Excuse me, I'm struggling a little bit here. I've been sick. You would need to do that through the grid port. And so showing that, that would be coming through a transfer switch. And a nice thing that this does is it leaves that generator port open, and you could use that as a load output as well. So that's a nice feature. You could also use it to bring in AC coupled solar. So I'm showing you, if you've got a Briggs & Stratton transfer switch, one of the things you're going to want to do is make sure that AC coupled solar won't backfeed the generator. And you can do that with a line voltage lockout module. So typically those homes that already have AC coupled solar on the roof, we already know, AC coupled solar doesn't give you any backup in an outage. So adding a battery-based system like a Sol-Ark, you can bring in that AC coupled solar. Typically you're looking at 20 amps or 40 amps of AC coupled solar. But you don't want that solar running if the generator's running. And because that generator's coming through the grid port, we recommend installing a lockout module like this SimpliPHI 2. The other thing you can do is use one of these PSP products. So if you aren't using a Briggs & Stratton transfer switch, you can install one of these PSP products. These are lockout latching relays, and they're programmable. They come in 60 amp, 100 amp, 200 amp versions. Likely you're just going to need a 60 amp version, because most systems that have AC coupled solar are 40 amps or under, just based on the common 120% rule for a 200 amp service would be 40 amps of AC coupled solar. So some examples. This is a link here for you if you haven't encountered that product before. I've provided some links throughout this presentation. You'll all be getting a copy of these slides as well as the recording. So some features of the Sol-Ark 15K. It is capable of 12 kilowatts continuous from batteries alone. If you've got solar and batteries, it's capable of 15 kilowatts of sustained output. But if you've got air conditioning, etc., you can surge to 24 kilowatts for 10 seconds. So that's to start your compressors on large air conditioners, or a large well pump, something like that. So it does have that ability to surge up to 24 kilowatts. Bring in 19 kilowatts of DC coupled solar through 3 MPPTs. It can continuously produce 15 kilowatts from that solar. Typically, you can oversize your solar array, so you're getting longer hours of full production and covering all your loads that way. 200 amps of pass-through, 100 amp fused connection on the smart load port. But that is derated down to 80 amps for continuous power pass-through. Same for AC coupled solar. You can do 80 amps continuous. It's got built-in two-wire starts. That's great. It can automatically start and stop the Briggs & Stratton generators almost out of the box. Just a little bit of programming there. And we can stack up to 12 of these inverters in parallel. The battery that we've developed specifically to support applications with inverters like the Sol-Ark 15K is the battery you can see on your screen. It's a stackable battery, very fast, easy to install. I've done a bunch of installs myself. I'm unbiased in saying that I love this battery. It's been a very great battery for us in terms of performance, just exceptional performance in the field, almost zero issues with it. And beyond that, it's got a great warranty on it. We give a 10-year unlimited number of cycle warranties. So our warranty is truly one of the best on the market. The warranty that we give doesn't limit the number of cycles. There's no throughput limit on it. You can cycle this battery as many times as you want, and we still guarantee that it will have 75% of its original capacity after 10 years. So a very strong warranty on it. It also has a very high power output. So one of the nice things about this battery is it can be cycled very fast. 0.75 charge rate is what you're seeing tested there. 100% depth of discharge, and you're still looking at over 4,500 cycles. 0.5 charge discharge rate, that would be a 2-hour charge, 2-hour discharge. 100% depth of cycle, you're over 6,000 cycles based on our lab testing. It also uses LFP chemistry, which is the only chemistry that you should be using on residential home backup at this time. It's safer, more cycles. There are a lot of advantages to LFP battery chemistry. These batteries can be combined, and I'm going to be talking about how to do some of the settings here in a little bit. We can do stacks, single stack of batteries. You can do double stack of batteries, triple stack of batteries. You can do up to 6 of these stacks for a very large system, 120 kilowatt hour system. So for residential backup, typically the limit in a location like a garage, you're going to need to follow the code, and that's typically limited at 80 kilowatt hours by the NFPA. We also have other solutions, 9540 certified cabinets. These are outdoor NEMA 3R enclosures. And like I said, these can come with heating options. So if you're interested in having heated batteries in a cold outdoor environment, you could utilize these. We have plug-and-play solutions as well. The Access Integrated System is one of these cabinets with a built-in inverter and pre-programmed. So very easy to install. And these have been a strong seller as well. I've put, even though this is a talk on whole home, and even though we're featuring mostly the Sol-Ark 15k, I did put together this slide about a year ago just so that you would have the specifications of the full Sol-Ark inverter lineup in a single page. The Sol-Ark 30k and 60k on the right are native 3-phase inverters, so they require a high voltage battery. So you can't use a Sol-Ark 30k with the batteries we're showing on the screen. Briggs & Stratton does make high voltage batteries. The 60k inverter is a native 480. The 30k is a native 208. We can also produce 208 with the 12k and 15k Sol-Ark inverters. And so if you're interested in 208, you can do 2 legs of 208. So if you're in a shop like mine that has 208, you can do 2 legs of 208, take in 208 power. You can do balanced 3-phase with 3 inverters. So if you're going to feed back to the grid, you'll need to do balance. But you can do those with the low voltage inverters as well. It is important to keep in mind when you're designing a whole home system to make sure you have enough battery power to cover the full demand from the inverter. So for a Sol-Ark 15k, a single inverter can pull up to 12 kilowatts out of batteries, and you need to have a big enough battery bank that battery bank's output can match the inverter's demand. So the number of batteries recommended batteries is there on the screen. The 6.6 batteries, 3 of those 6.6 batteries will meet the full demand. You get 273 outputs with 3 6.6s. So just a single stack of 3 batteries will work with a Sol-Ark 15k for whole home backup. Of course, the amount of energy you can hold in 3 batteries will give you enough backup. It varies depending on the home. On my home, which I have a fairly low power demand, I can get about 30 hours of backup from a stack of 3 batteries. The average amount of backup time will probably be more about like 18 hours for the average home in the US with a single stack. Double stack is probably the second most common installation. We'll see 2 stacks of 6.6 batteries and a Sol-Ark 15k for a whole home backup. Typically, you'll get a couple of days of backup, or at least a day and a half of backup with 2 stacks like this. And the nice thing about the Sol-Ark is you've got dual DC inputs. And so you could bring power in from both battery stacks through their own independent 200 amp breakers, as shown on the right side of the screen. If you are doing a single stack of batteries, we still recommend running dual cabling, bringing one set of cables to each of the inputs on the Sol-Ark. That makes the cable pulling the cable easier. It's easier to work with dual 1-aught or dual 2-aught cables. As well, each of your individual cables would then be protected with the individual breakers there. So if you use dual 2-aught, which is my preference, then your cables are protected. If you're doing multiple inverter systems, or if you're doing more than 2 stacks of batteries, you're going to need some type of battery combiner. So, there's an example I'll show in a little bit of a system with 4 stacks of batteries, right? And that utilizes the Midnight 1000 amp combiner on the left side of the screen. What you see here in this is a combiner, but these are individual inputs. So single pole breaker, DC breaker on the positive cables coming in. And you've got, it looks like 6 different inputs on this 1000 amp combiner. You can use power distribution blocks, but you will still need to provide overcurrent protection for your combiners. And so we're recommending overcurrent protection. Typically, we see 300 amp breakers. The maximum you can use on each stack could be a 350 on your combiner. Class T fuses give you a nice option for doing that. So you can put, the batteries will protect themselves. The BMS has digital overcurrent protection built into it. But these Class T fuses are a nice option. And let me show you a great example of a very low cost combiner. So these Victron 1000 amp DC combiners, and make sure you do get the one with the M10 lugs. So that's M10 is the size of the studs that are here. You can then provide individual overcurrent protection on each of your inputs. And so these are stackable. They're only about, I think this link here that's here on the screen, these things are about $160 each. And the fuses, typically you buy a pack of those fuses for about $35 each. This is a very low cost way to do a combiner. When you do use these as a combiner, as I'm showing 6 different inputs here on the screen, please pull off of opposite corners. So pull positive off of this corner, negative off of this corner, and that provides the most overall balance. And Paul, I see you've written here, I have a unique solution that I need to discuss with someone. Feel free to reach out to us. They have fleet vehicles, processing servers on board with gas generators and power. However, we need to switch to a battery-based solution. Paul, I'd be happy to talk with you afterwards or connect you with our application engineer. So just go ahead. If you have questions, go ahead and pop them in there. I will respond to that one, Paul, afterwards. And everyone, feel free to ask questions if you have them. So I really like this option. In fact, I have this option in my shop with 2 of these 1000 amp stacked combiners, and it's essentially 25% of the cost of others. And then you've got this great manufacturing from Victron. It's a well-designed combiner. Also, if you do need a DC disconnect, be careful. 48 volt rated disconnects are not really rated for the appropriate voltage. A LFP 48 volt nominal battery will actually go up to 56 volts. These Rincon switches, so switches can be a point of failure. These Rincon switches can be locked in the off position. They have the UL certification, and these go up to much higher voltages. I think they're rated at 600, even some of them are at 1000 amps. About $100, maybe a little more than that now. But these Rincon switches are a nice example, and there's a link there for those as well. All right, so combining battery banks is important. Let's talk about wiring. So in a Sol-Ark 15k, you have a section on the left side of the inverter for DC inputs. The DC inputs, you've got 2 positive inputs. Both of those positive inputs have their own individual breaker and then are combined on a common DC bus after the breakers. So this is a nice option. You can actually use the dual DC inputs on a Sol-Ark 15k as a battery combiner for 2 stacks with individual 200 amp overcurrent protection on both of your inputs. Then your negative battery connections are here. In the center is a comms board, but on that comms board is also the input for the DC solar. So this is independent MPPTs. 4 of these lever cam lock uh, uh, inputs go to each MPPT. So positive, negative, positive, negative. And so these are your solar inputs. The MPPTs, sorry, positive, positive, negative, negative. These MPPT inputs you can use to parallel different strings of solar here if you don't have a combiner up on the roof. And then here on the top, these are paralleling communications. Those are RJ45 jacks for a typical Ethernet cable, Cat5 cable. I recommend you use shielded if you're putting it in the conduit with other cabling. And this is RS45 output. It can be CAN bus, Modbus. This CAN bus port here is what you would use to communicate with our battery BMS systems. So paralleling would be if you have multiple inverters paralleled. CAN bus here would be a single CAN bus line to one of our batteries. We'll provide all the communications for the entire stack of batteries. And then this is the generator input. The grounding bar is up here, and then you've got a neutral bar, common neutral bar on the bottom for split phase applications. And then the load output is here. You do have a disconnect on that load. And then the grid input here, you can accommodate up to 4-aught aluminum or 3-aught copper is typically used for your connections on 200 amp service. Showing the use here, this is one of our SimpliPHI batteries. Closed loop comms with these batteries. Notice the use of the terminating resistor here. Those come with the batteries. You do not want to have an open port with a CAN bus communicating battery bank. So if there is any open port on the battery communications, you won't have accurate readings. And then one final home run from the battery bank device port into the inverter's battery CAN bus port. Showing that here as well. And then pins 7 and 8 on the comms bar are used to do 2-wire start. So that's what allows the inverter to start and stop. It's a normally open dry contact. And so when it does call for a generator signal to start, it will close those dry contactors that will then create a continuous pathway through pins 4 and 5 on our generators. And so that's what will initiate your 2-wire signal to start. On the vertical, the wiring bay looks like this. On our horizontal generators, the wiring bay looks like this. Pins 11 and 12 here are also worth pointing out. That's your rapid shutdown button, or your rapid shutdown transmitter. And then some more pinouts here from that Sol-Ark 15k. The emergency stop, which I called 11 and 12, that's BB. It's labeled BB actually if you zoom in on the board there. So that's where you would wire your rapid shutdown. That's a normally open rapid shutdown. So when you depress that button, it closes that circuit, and then it will shut down the transmitters for rapid shutdown, pins 15 and 16. The emergency stop would also stop all output of the inverter. So the AC output of the inverter, the loads would come down with rapid shutdown. So almost every jurisdiction is going to require that rapid shutdown button. It should be a switch mounted on the outside of the house. I encourage the use when you're installing a Sol-Ark 15k of a wiring trough, like as an example here. It might be a 10 by 10 or a 12 by 12 by 48 wiring trough underneath. It does help with wire management. So you can see this one's mounted under these load centers and disconnects that are here. And you can combine inside these wiring troughs with power distribution blocks, etc. There are even some when you are doing this, of course, you're going to have to punch the holes, and there are even some companies out there. I've got a link here to Practical Preppers showing that they've made a template that you can buy. You can make your own template, of course. If you do a lot of these, that can be quite helpful. So let's talk about how to set up the batteries. So once we do this is an example of a system that I've built. This is a training wall. This sits in my shop. And we take this to various training events. We have a number of these. And so if you're interested in in-person training, reach out as well. We might have one coming to your area. We did one in Pittsburgh last week. We did one in Madison, Wisconsin this week. And we have 5 different trailers traveling the country to do in-person trainings. Well, we'll bring an example of a training wall like this one. The battery is here. We're showing a 2-aught conduit being run. I used seal-tight in this example, or liquid tight in this example, but metal line flex. The batteries should come with a pre-punched plate on the side for a 2-inch conduit. So whether you use an EMT or an LR here at the top, there are different ways to run that conduit. When you're first turning on the Sol-Ark, so the Sol-Ark itself then has an AC power supply, so there's a 200 amp service panel with a 200 amp disconnect here. That power comes in through the utility port on the inverter and then goes out of the inverter to the load center in this example. So when you first are turning on the inverter, you'll see a screen that appears like this. There's a gear icon there. It is a touch screen, and then you have the ability to change settings using the up and down and the enter and back buttons, escape buttons. You can also see that this one has an energy track gateway for monitoring, and that'll give you individual information about each of the battery modules that's on your system. Can be very useful for large battery-based systems to know information about each individual battery. Once you've enabled that battery communication with the inverter by checking this box for BMS lithium battery with a default address of 00 there, and then clicking OK. OK on a Sol-Ark is essentially save. It's remember. So when you click OK, you should see the battery capacity automatically appear. Settings for a whole home battery backup system. So your max overall charge and max overall discharge, these are amps DC. And under the battery tab, you have a max charge and a max discharge rate. These are global limits. And what I mean by global limits is they incorporate solar charging at the same time as maybe grid charging. So you might have 20 amps. If I set my max charge rate at 100 amps, you might have 20 amps coming from solar and then 80 amps overall coming from the grid. So it will limit the amount of charging, combined charging to this value. For a single stack of 6.6s, this can be 195 amps DC. The max the Sol-Ark will do, I think, will be 270 amps. And then the max on the discharge side, you would set it at the maximum. A Sol-Ark 15k will pull at 50 volts, will pull about 250 amps of discharge out of the batteries. You can go ahead and set that at the maximum value, which is 273. It will automatically, the BMS will automatically select use battery percentage. That's what most customers prefer. And so if you do have a communicating battery, it'll set that. If you don't have a communicating battery, you can choose to use voltage. And best practice with these battery systems is to actually set up without communications first, so that if communications are ever lost, then the inverter will default to those values. So the first step might be, and best practice would be, to go through a program with voltages without communications enabled. We would set our float at 54, our absorb at 56, and then the equalize we disable by setting that to 0 hours. The equalize is a lead acid function to burn sulfur off the plates. For charging sources from AC, when you click on the charge tab on the top, you have the ability to independently set the rate of charging from the generator or from the grid ports. And so from the generator port, this is showing 40 amps. It's grayed out because this box is not checked. If you have voltage checked over here, then you would be setting the start value with a voltage. If you have percentage checked, then the percentage box would be what you are able to set. By checking the grid charge box, this allows the battery to charge up off of grid. You can limit the amperage at which that happens. The start percentage that's here, that percentage is what's used to automatically start a generator if you have a generator connected to the grid on the right side, or if you have the generator connected to the gen port on the left side here. So that start percentage, once that battery hits that value, if the grid is down, it will automatically start the generator. And provide that starting. If you're trying to test out your system and you've done your settings and you want to test out your generator, you can click this box for force gen and then click OK. And that will automatically start up the generator. You can uncheck the box, click OK again, and it'll stop the generator. So you can test your two-wire start that way. Under the discharge tab, so the shutdown voltage is the voltage if a battery hits that, at which the inverter will shut off loads. If you have it as a percentage, For systems that are cycled daily, we recommend a 20% value there. 48 volts is what we would recommend would be 100% depth of discharge. The battery empty voltage should be set at 48 volts. Low battery is when the inverter will indicate to the homeowner that the battery is getting low. We typically recommend somewhere around 49.5 volts, which would be about 15% overall battery capacity, 20% battery capacity for low voltage if you're discharging all the way for a occasionally cycled battery. For a battery that is going to be cycled daily, we'd recommend these values at 30%. And then 50 volts here for low battery. And that's when the inverter will just start giving you a beep indicating to you that the battery's getting low. Restart is if the battery has hit a low voltage shutdown and actually the inverter has shut loads off. It will allow the battery, if you have solar on the system, to charge back up to this value before starting discharge again. That way you're not having the inverter turn loads on and off when the loads are a little more than the solar can supply. Battery empty voltage should be set at 48, as I said earlier. Battery resistance. So the battery resistance overall should be for a 3-stack of batteries about 8 milliohms. It's essentially it's the resistance of a single battery divided by the number of batteries in your bank. So for a 6.6, that's 20 milliohms divided by the number of batteries. For 3.8, that's 24 divided by the number of batteries. But if you've got a communicating battery, this will be set automatically. We do have the ability with the Sol-Ark 15k when we're doing whole home backup to do different things. One of the things that we can do is we can export excess solar back to the grid. We can limit how much excess solar we're selling back to the grid. So if you do have a limited agreement with your utility provider, or if you're sending back through a partial backup system and you're sending back through a main load panel and you don't want to go over the 120% rule, which would specify 20 amps back on a 100 amp panel, 200 amps, or 40 amps back on a 200 amp panel, you can set that value here. Limited power to home, what that will do is it'll use the CTs that come with the inverter. I'm showing those in the bottom right corner. And limited power to the home is going to limit how much overall power you're going to pull from the grid. And so you can use batteries to supplement the power being pulled from the grid so you don't exceed a certain value, which can be nice for avoiding things like peak demand charges. You could also do limited power to the load. If you're only backing up part of the home, this can be useful. And then time of use settings, as I talked about a little bit earlier, time of use settings allow you to export or import power from the AC bus into the battery. So the example that's shown here with this time of use box checked, you can also set up seasons by clicking the setup. But by checking this box, I can specify, if I check the charge box, that I want to charge my battery between 1 a.m. and 5 a.m. at 2,000 watts. If the battery is below 50%. As soon as the battery gets up to 50%, it would stop. So if I click the charge box, that's what would happen. If I have the sell box checked, it will also sell excess battery power until the battery gets down to 50%, right? And so you can choose different periods to charge or sell battery power based on the rates essentially, or the times that you want to use battery power to offset the pulling power from the grid. So this can be a very nice way if you do have time of use rates to either buy electricity when it's cheap or to charge up during the day and then discharge at specific rates throughout the night. I did point out that you can do 3-phase power by paralleling multiple inverters. And so you can check the box for split phase. If you're doing a typical residential, I think by default it's going to come with that. But you can do 120, 208 3-phase as well. And so with multiple inverters, you can do balanced 3-phase. If you're just looking to bring power in from a 120, 208 3-phase system, you can also do that on just a single inverter. You can bring 2 legs of power in. Paralleling systems is relatively easy, but we don't have time to cover that here. So I'm showing an example of the inverter here being used to retrofit. So we might have had these initial, the installer here probably had these initial inverters up on the home. They had AC coupled solar. So those string inverters there, those are solar edge inverters, probably 20 amps each. Those were not providing any backup power, right? And so it looks like this customer wanted to have battery backup. And instead of getting on the roof and tearing off the solar edge optimizers, rewiring the solar panels that's on the roof, you can just leave those inverters there. They're already permitted, they're already done, and you can bring them in through the gen port on the inverter. If grid goes down, now you have battery backup, but there's also another advantage. If the grid is down and the batteries get low, right? That solar is still active. So the Sol-Ark inverter is a grid forming inverter, and so it can keep that solar active. That was something that those customers wouldn't have had without a battery-based system like this. Then a nice looking retrofit install that's here. Here's an example, as I said before, this is showing you that this is a 24 by 30 inch, 36 inch midnight combiner. And so that combiner's got individual DC inputs. So there are individual breakers that are on the right side and the left side, bringing in up to these got 4 stacks of batteries here. And then we've got 2 Sol-Ark inverters that are paralleled here. Very large amount of solar on this complex. It's actually an off-grid system, and there's a Briggs & Stratton generator there that can supplement if those batteries do get low and the solar is not available to charge them up. That generator can start up and cover that. And so you're seeing an example of the generator power, PV power. Generators essentially just off in this example. And then you can see those batteries. There's not much discharge happening for the SoC, but you get nice monitoring through that Sol-Ark app as well to cover this. You can scale our batteries and our power sources independently. So here you can see dual Sol-Ark inverters. Maybe we're processing a large amount of solar. We just want a little bit of backup to keep the solar active if the grid goes down. Well, we can absolutely scale the power and the capacity independently of each other. Here on the right side, we're looking at an example. I think somebody just told me this was theirs at the training in Pittsburgh last week. So this is out of JB Solar out of Pittsburgh, Pennsylvania. You're looking at dual stacks of batteries here. And that's powering a Sol-Ark 50k or 15k. So you're looking at 4 stacks of batteries, and he's got built in a bypass switch here too. So if he ever does need to do work, he can turn the solar off, but still bypass that system, which is really best practice. This is a very nicely designed system. Common system size here, 40 kilowatt hours of energy storage. That's the equivalent of about 3 power walls, a good amount of backup power there. But it could allow you to do self-consumption at nighttime as well. So if you're producing solar power, you essentially can get very little from the grid. You can essentially produce your own power. I like the example on the left here. This is fire retardant plywood. It is available, at least out here in the West Coast. I like it because it shows the example of parking ballards. So this is installed on the side of the garage, and you can see that opening to the garage is quite close to where the batteries are. So just to prevent vehicle impact, they've installed parking ballards here. We've also got these batteries up off the floor. So if there was a flood prone location, there's an advantage of having these batteries be wall mountable. On the right side of the screen, here's another location in a garage. Probably this is protected by a wing wall, showing dual battery stacks here with the use of a wire gutter. Here's an example in which I'm actually in this picture installing these batteries with some guys locally here. These batteries can be fairly easily lifted into place with just 2 guys. The batteries are about 130 pounds a piece, the modules, and so it's not light, but it's quite reasonable for two installers to put these stacks together. The whole battery system for this install went together in about 30 minutes, so quite quickly. Now there's plenty of time that was spent. We had 18 kilowatts of AC coupled solar coming into this one. But compare that, the 130 pounds per module of this rackable system to the other options that are out there, and you don't need a special lift. That's a really nice thing about this modular design. There's also redundancy to multiple batteries as well. Many customers are asking for inputs. So this is an input that can cover portable generator. So you can bring a generator in as well. And then here in the middle, it's a nice looking installation where they've used an LB here, a 2-inch LB to bring that battery conduit into a wire gutter underneath a Sol-Ark. I would caution though that you should have space underneath the Sol-Ark. to allow for air to be brought in through the fans there. And so this wire gutter here does not extend all the way back to the wall. They've kept the back open for airflow. There's also the energy track gateway included in each of these systems on the right. Here are some examples of systems. This is using the Boss 6 cabinet. So it's got 25 kilowatt hours of storage inside it. You have the ability to put heaters in with this example as well. This is a nice looking system where they've chosen not to do a wire gutter underneath. And it looks like they've got an input or an output below. That might be a generator input below the inverter there. Here's an example of an access cabinet. We showed that earlier. And then here's some of our more traditional batteries. So these are examples of our PHI batteries, and we've often seen PHI batteries with really large systems, as I'll show you. So we have a 15-year unlimited number of cycle warranty on our SimpliPHI batteries. It's a very long-lasting battery there. It has the ability to bring heaters directly into the battery, which is much more efficient than in heating an enclosure itself. Here's an example of a high voltage system. So we've got a very large number of high voltage projects across the country. We have the ability to integrate with different inverters, including the Sol-Ark inverters, but also the Oztech inverters that are not hybrid inverters. So they're not designed to bring solar in, but if you're just looking at a strictly battery-based backup system, you can use those Oztech. Here's an example of bus bars being used. It nicely shown that they're pulling power off of opposite corners of the bus bars. That's best practice to keep the battery system balanced. Large installations here. This one's showing looks like 7 or 8 Sol-Ark 12Ks there, running off a very large system with custom DC bus bars here. That's done up in Alaska by Wolf Creek Solar. And then AEGIS is out of, I think, Connecticut, where they've done 7 different Sol-Arks on both sides of this wall, paired with 95 batteries for large backup systems. So we see those. There are some advantages to our SimpliPHI batteries as well. So one, we can integrate heaters, but we also have a clever way of using the batteries to generate heat. So the viscosity of batteries goes up, internal resistance of batteries goes up at low temperatures. So it's less mobility for the ions as they're migrating through the electrolyte, and that results in the generation of more heat. So a less efficient low temperature battery can heat itself up, and so we can ramp the rate at which we heat that battery up during a discharge cycle, or even by charging slowly, allowing the battery cells themselves to get warmer and then increasing that charge rate. So we have an expanded charging temperature range for our batteries that normally exceeds the competition. So this battery will charge all the way down to -4 Fahrenheit. So it's quite a low temperature. And again, we can integrate heaters. So here's an example of a heating system that's being integrated in, and those heaters go directly on the batteries themselves, which is more efficient than heating an overall cabinet. Here's an example of heated system. This is installed up in Buffalo, New York. We've got parallel Sol-Ark inverters and then these outdoor cabinets with heated batteries inside. We also make a 2,000 amp combiner by using the Boss 6 cabinets as well. So if you need to do a large system, we have that option. One of the nice things about whole home backup with the Sol-Ark 15K is that you can monitor all of your different fleets, all of your different power plants that you've installed with the Sol-Ark platform, the My Sol-Ark platform. You can also change configurations remotely. And if you need help and you share the system with us, we can also change those settings remotely to optimize your system. So this is something we do with our customers. It's one of the reasons why you choose an American-based company, is that we offer a lot of support, right? We're there when you need us. Here's an example of a system. This is what you can see with your monitoring platform, but there's plenty else that you can see. So you can chart your production. Whenever the battery is going negative, like that means the battery is pulling power in. And then when the battery is positive, the battery is discharging. This customer must have time of use set up, as you can see, by their charging or discharging up until 8 p.m. and then saving some reserve battery, likely for loads the next day. You can also see with our communicating batteries a lot of information being pulled in through the Sol-Ark. So you can see the BMS temperature, the battery cell temperature, voltage, state of health. All of these things are monitored inside that Sol-Ark app. If you're looking for more detailed level monitoring, maybe you have a system that's going to include 24 different SimpliPHI batteries, and you want to know how every battery is doing. Well, then the Energy Track Gateway that Briggs & Stratton produces gives you a nice opportunity to see detailed battery information on each one of the modules connected. And so we sell that gateway, and you can ask about that to our sales team if you're interested. So I'm here at the top of the hour. We've got a little bit of time for questions. So if you have any questions, feel free to pop them into the Q&A. If you've never installed one of our systems before, well, then you're eligible to get $1,000 off your first installation. So you can take advantage of that. If you sign up for our Elite Installer program, you also get $100 back per battery that you install. So if you install a single system with 10 batteries, you can get $300 or $1,000 back off that system. Install a single system with 3 batteries, get $300 back off that system. So if you want to be a Briggs & Stratton installer, one of the things that can do is help us direct business to you. So let us know. We'll get you on our map, and then we can send leads your way as well. It's a good program to take advantage of. And that $100 battery off adds up. So we process those quarterly. If you've installed 24 batteries in a quarter, you get a check for $2,400. It's a good offer. So I encourage you to reach out with any questions. If you're here again for your NABCEP certificate, please do send an email to this address, energystoragetraining@basco.com, and tell us how your name should appear on the certificate. I'll get those issued and out to you tomorrow. So if there are any questions, go ahead and pop them into the Q&A. And if there are no questions, then I'll end a little bit early. Okay, so thank you, everyone. I do appreciate your attendance. Paul, I will get back to you, so thanks for reaching out. I'll have somebody get back to you to discuss the use of your system and installation of batteries. For the rest of you, enjoy the rest of your day, and have a good weekend as well. All right, bye, everyone. Thank you for being here.